Hello my dear students. At this class I am going to discuss various types of equations of a plane. In the last class already I have started the part plane, okay, and I have discussed the first type of equation, that is equation of a plane in normal form. In the last class I have discussed and I have given the there is examples also, okay. So today I am going to discuss some more types of equations of a plane, okay. जैसे straight line में भी different types of equations था, similarly in plane also we will get different types of equations, okay. So the second one is, why I am saying the second one, because already I have discussed the first one in the last class. The second one is equation of a plane perpendicular to a given vector. ठीक से देख लेना, हेडिंग में ही सब कुछ दिया हुआ है, हिंट, ओके. Equation of a plane perpendicular to a given vector and passing through a given point. Equation of a plane perpendicular to a given vector and passing through a given point. अभी ये डायग्राम देखना है. This is the plane. Here n bar, you can see n bar is perpendicular to this plane. ये जो black color का जो box है, this is a plane. And this small letter n bar is perpendicular to this plane, okay. This means it is 90 degree perpendicular है plane के ऊपर, okay. This is plane and this n bar is perpendicular. मैं ये डस्टर से दिखा रहा हूँ. This is suppose the plane and n bar is perpendicular to this plane, okay. This n bar is perpendicular to this plane. OA. So here A is a point through which the plane is passing. The coordinates of A x1, y1, z1. Okay. And P be any point on the plane. Without unknown variable we cannot construct any equation. तो इसीलिए P तो चाहिए हमेशा. So P be any point on the plane whose coordinates है x, y, z. Okay. Let A bar, small letter A bar, be the position vector of OA and small letter R bar be the position vector of OP. Okay. फिर से मैं हेडिंग दिखा रहा हूँ. हेडिंग से ही सब कुछ पता चल जाता है क्या होगा. Equation of the plane perpendicular to a given vector and passing through a given point. This plane is perpendicular to a given vector n bar. Yes, n bar is perpendicular to this plane and it is passing through the point A whose coordinate x1, y1, z1. Of course, without P we cannot construct any equation. So that's why you have to consider a general point, or you may say arbitrary point P on the plane whose coordinate x, y, z. Okay. Then the vector equation of the plane, passing through a given point, which point here? Passing through a given point, say A, passing through a given point A with position vector A bar. The position vector of OA is small letter A bar and perpendicular to a given vector, which vector? N bar is perpendicular to this plane, perpendicular to a given vector n is R minus A dot n bar is equal to 0. This is the vector equation of a plane perpendicular to a given vector and passing through a given point. Passing through a given point means here A bar is the position vector of the given point, capital letter A, whereas n bar is perpendicular to this plane. So this is the vector equation. Derivation is not required for this equation. सो इसीलिए मैं सिर्फ इक्वेशन दे दिया. वेक्टर इक्वेशन इज, द वेक्टर इक्वेशन ऑफ द प्लेन इज r minus a dot n bar. Don't use n cap. N cap we will use only in case of first type, that is equation of a plane in normal form. इसका था r dot n cap is equal to d. वो first type of equation में था, but not in case of the second one. Okay, r minus a dot n bar equal to 0. This is the vector equation, right? Similarly, now if you want to find the Cartesian equation, the Cartesian equation of the plane is, कैसे फाइंड आउट करना है? वेक्टर से कार्टेशियन में कन्वर्ट करने के लिए हमेशा याद रखना है कि you have to replace this r bar, a bar and n bar by the vector components. That is, say r bar is equal to xi cap plus yj cap plus zk cap. We are considering r bar is equal to x because r is the position vector of OP and the coordinates of P are x, y, z. Okay. A bar is equal to x1 I cap plus y1 j cap plus z1 k cap. Yes, A bar means the position vector of OA and the coordinates of A x1, y1, z1. And say small letter A, B and C, or you can write capital letter A, B, C also. Better you write capital letter A, B, C, no problem. Say A, B and C are the direction ratios of n bar. Okay, direction ratios of n bar. क्या क्या पुट किया? वेक्टर से कार्टेशियन इक्वेशन कन्वर्ट करने के लिए यू हैव टू पुट r bar is equal to xi cap plus yj cap plus zk cap. A bar is equal to x1 I cap plus y1 j cap plus z1 k cap. सब कुछ डायग्राम में ही है. And you have to consider capital letter A, B and C are the direction ratios of this n bar. N bar is perpendicular to this plane. Okay, फिर से मैं दिखा रहा हूँ. This is suppose the plane and n bar is perpendicular to this plane. So then the equation, if you put all these values, say r bar, a bar and n bar, if you put all these three values in this equation, then this equation will become a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. This is the Cartesian equation of the plane passing through a given vector and that is perpendicular to a given vector and passing through a given point. Okay, मैं substitute नहीं किया यहाँ पे, but you can check. If you put the values of r bar, a bar and the value of n bar in this equation, क्योंकि वेक्टर से कार्टेशियन में कन्वर्ट करने के लिए ये सब वैल्यूज वेक्टर इक्वेशन में ही पुट करना है. After substituting all these values, then you will get this equation only. A into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. Where a, b and c are the direction ratios of this vector n bar. And x1, y1, z1 nothing but the coordinates of the point through which the line, that is the plane, is passing. Okay, note down these two formula: vector equation of the plane, Cartesian equation of the plane, perpendicular to a given vector and passing through a given point. Derivation is not required, just formula you can check and maintain the diagram. Diagram थोड़ा clearly draw करो, हो जाएगा. Clearly draw करने से पता चल जाएगा कहाँ से ये formula सब derive हुआ. Okay, so this one is the second type. Next type, next one is equation of a plane passing through three non-collinear points. Equation of a plane passing through three non-collinear points. मैं इसका डायग्राम नहीं दे रहा हूँ, डायरेक्ट फॉर्मूला दे रहा हूँ. ठीक है. So the vector equation of the plane passing through three non-collinear points, say A, B and C, whose position vectors are small letter a bar, स्मॉल लेटर b बार एंड स्मॉल लेटर c बार, सब में ना डायग्राम ऑलमोस्ट सिमिलर टाइप का ही होता है. ओके, सो यहाँ पे ऑलरेडी मेंशन कर दिया कि इक्वेशन ऑफ ए प्लेन पासिंग थ्रू 3 नॉन कोलिनियर पॉइंट्स, मतलब 3 पॉइंट चाहिए. सो लेट द 3 पॉइंट्स बी a, b and c. So in order to write the vector equation, we should know the position vector of these 3 points. So let their position vectors are a bar, b bar and c bar respectively. A bar, b bar and c bar. Okay, and let p be any point. मैं इसका डायग्राम नहीं दे रहा हूं क्योंकि डायग्राम ऑलमोस्ट सेम है सब में. p be any point on the plane. Say r bar be the position vector of OP bar. Actually all these 3 points are passing through the origin only. ठीक है, चलो मैं एक रफ स्केच दे रहा हूं. There are 3 points. A ऐसा जा रहा है, B सपोज ये है, C, A B C. Okay, and another point say here P. So all these points passing through the origin only. Okay, so इसीलिए लिखा के R bar with the position vector of OP bar. Then the vector equation is R bar minus A bar B minus A cross C minus A bar is equal to 0. This is the vector equation of the plane passing through 3 non-collinear points. R minus A dot B minus A cross C minus A. R bar is the position vector of OP bar, where P is any arbitrary point on the plane. A bar is the position vector of the point A. B bar is the position vector of the point B, whereas C bar is the position vector of the point C. So this is the vector equation. Note down this equation. No need to write the derivation. R minus A dot B minus A cross C minus A. Whereas the Cartesian equation is very simple. Determinant x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1 is equal to 0. Okay, determinant form है. This is determinant. X minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1 is equal to 0. This is the Cartesian equation of the plane passing through 3 non-collinear points, where x1, y1, z1 are the coordinates of A, x2, y2, z2 are the coordinates of the point B, and x3, y3, z3 are the coordinates of the point C. और एक बार, after expansion, this is determinant, that means you have to expand it. So after expansion, if you will get exactly 0, that means we can say that the 3 points are not non-collinear, the 3 points are collinear only. Okay, after expansion, if we will get 0, then we can say that the 3 points are collinear. ठीक है, so these are the 2 equations, vector equation and Cartesian equation of the plane passing through 3 non-collinear points. Now I will give one example of these 2 equations. Okay, so the first example I'll give this one only, equation of the plane. So the question is, इसका ही मैं एक एग्जांपल दे रहा हूं. Find the Cartesian equation of the plane. Find the Cartesian equation of the plane passing through the points, say A 2, 2, minus 1, B 3, 4, 2, and C 7, 0, 6. You are asked to find the Cartesian equation of the plane passing through 3 points. Since here 3 points are given, so that means we have to use this formula only. Cartesian मतलब यही formula use करना है. No need to use this formula. Okay. So the solution is very simple, very simple. So determinant x minus x1. x1 means here 2. y minus y1. y1 is also 2. x1, y1, z1 का value है. z plus 1. Similarly now x2 minus x1. This is x2. x2 minus x1. 3 minus 2, that is 1. y2 minus y1. 4 minus 2 is 2. z2 minus z1 is 3. x3 minus x1. x3 minus x1. 7 minus 2, that is 5. y3 minus y1. 0 minus 2 is minus 2. z3 minus z1 is 7. This is equal to 0. You have to write 0. You have to write 0. लेकिन expand करने के बाद अगर left hand side में भी 0 आ गया तो that means we can say that the 3 points are collinear. Okay? तो चलो Cartesian equation find out करना है. तो expand करना है. So here the first element is x minus 2. You know how to expand. Delete the position of the first element. 14 plus 6 minus y minus 2 into, again delete the position of now the second element, that is 1 into 7, 7 minus 15 plus z plus 1 whole into, delete the position of this, 1 into minus 2 is minus 2 minus 10, this is equal to 0. So if I expand it, you will get 20x minus 40. 7 minus 15 is minus 8, so this will be plus 8y, minus minus plus, plus minus minus, so minus 16, minus 2 minus 10 is minus 12, minus 12z, minus 12, this is equal to 0. That is 20x plus 8y minus 12z minus 40 minus 16 is minus 56 minus 68 is equal to 0, which is the Cartesian equation of the plane passing through 3 non-collinear points. Now it is clear that it is confirmed that these 3 points are not collinear. These are non-collinear only, and you can check the equation in the first class. That means in the last class I have given the equation Lx plus my plus nz is equal to d. तो वही फॉर्म में आया ना कार्टेशियन इक्वेशन. यस, Lx plus my plus nz is equal to, ऐसा फॉर्म में ही आता है. ठीक है, कार्टेशियन इक्वेशन अल्टीमेटली एक्सपांड करने से वो स्टैंडर्ड फॉर्म ही कन्वर्ट हो जाता है. ठीक है, सो दिस इज द कार्टेशियन इक्वेशन ऑफ द प्लेन. सम मोर एग्जांपल्स आई विल गिव एंड इवन सम मोर इक्वेशंस आल्सो आई हैव टू एक्सप्लेन. ओके, सो द नेक्स्ट टाइप इज equation of a plane in intercept form. Okay, intercept form of the equation of a plane. In class 11 we got in straight line, that is equation of a line in intercept form. Equation of a line in intercept form. वो क्या था? Equation of a line in intercept form means, suppose there is a non-vertical line AB which makes intercept, say small letter a with x-axis and small letter b with the y-axis, then clearly we can say that the coordinates of a be a comma 0, whereas the coordinates of capital letter b be 0 comma b. Then the equation of the line is x by a plus y by b is equal to 1. This one is the equation of a line in intercept form, जो कि class 11 में मिला था. Okay, now in class 12 you have to write the equation of a plane in intercept form. Okay, suppose there is a plane PQR in space. There is a plane PQR in space with the intercept, or having intercept a, small letter a, with x-axis, b with y-axis and c with the z-axis. Again I am repeating, suppose there is a plane PQR in space having intercepts A on x-axis. Intercept means what? Intercept is length only. Having intercept A on x-axis, B on y-axis and C on z-axis. Then the equation of the plane in intercept form is x by A plus y by B plus z by C is equal to 1. This is the equation of a plane in intercept form. ज्यादा कुछ डिफरेंस नहीं है. दिस इज टू डायमेंशनल जियोमेट्री, इसीलिए एक्स और वाई एक्सिस आया. दैट मीन्स एक्स बाई ए प्लस वाई बाई बी इक्वल टू 1, जो क्लास 11 में मिला था. इन केस ऑफ प्लेन विल गेट 3 axes, right? X, y and z axis. So that's why the equation is x by a plus y by b plus z by c is equal to 1. Now since the plane PQR makes intercept A along x-axis, so that's why we can write the coordinates of P a comma 0 comma 0. Of course we know any point lies on x-axis in case of three-dimensional geometry is x comma 0 comma 0. Yes, in two-dimensional geometry any point lies on x-axis x comma 0, because यहाँ पे तो सिर्फ x और y axis ही आता है. Yes, so that's why we can write a comma 0 comma 0 since the length is a. Similarly, since the plane PQR makes intercept B with the y-axis, small letter b with the y-axis, so that's why the coordinates of Q are 0 comma b comma 0. Yes, x और z coordinate 0 होगा अगर वो point y-axis में है तो. Like this, the plane PQR makes intercept small letter c with the z-axis. So any point lies on z-axis means x and y coordinates are always 0. That's why 0 comma 0 comma c are the coordinates of capital letter R. Okay, from this figure we can derive this equation. Derivation is not required, just you have to remember the formula. X by a plus y by b plus z by c is equal to 1, where a is the x-intercept, where a is x-intercept, b is y-intercept, and c is z-intercept. Okay, a is x-intercept, b is y-intercept and c is z-intercept. Okay, so ये हो गया intercept form of the equation of a plane. Now I'll give one example. Okay, I'll give one example. Reduce the equation. Question is reduce the equation, say 4x plus 3y minus 6z minus 12 equal to 0 into intercept form. Into intercept form, and also find x, y and z intercept, and also find x, y and z intercept. What is the question here? First of all, you have to reduce the equation. This is the equation. What kind of equation is this one? This is the equation of a plane in Cartesian form, that is Lx plus my plus nz is equal to d. D is the distance, perpendicular distance from the origin. In the last class I have explained all these things. Okay, this is the equation of a plane in Cartesian form. So you have to reduce this equation in slope intercept form. So to reduce, in order to reduce any equation of a plane into slope intercept form, first you should know the equation in intercept form. We know the equation in intercept form is x by a plus y by b plus z by c is equal to 1. So if you know the equation, then easily you can convert this equation of a plane into intercept form. So how can we reduce? Once you can check the right hand side part of the standard equation. The right hand side part is always 1. That means this is the constant part. So in this equation also the constant part is minus 12. Shift this constant on right hand side. This is the first step. बहुत आसान सा क्वेश्चन है, मैं स्टेप बाय स्टेप एक्सप्लेन कर रहा हूँ इसीलिए थोड़ा सा स्लो जा रहा हूँ. So 4x minus 3y, sorry, 4x plus 3y minus 6z is equal to 12 we can write. Okay, after shifting the constant term on right hand side, then you have to divide both sides by 12. Why? Because the right hand side part should be 1, but in this question the right hand side part is 12. So make it 1 by dividing both sides by 12. So if you divide both sides by 12, then the first term will be x by 3 plus y by 4 plus of minus z by minus 2. This is equal to 1. So why we need to write the third term like this? Because in the standard equation there is no negative sign. All are plus sign. So that's why you just write like this, because we know plus minus is minus only, meaning is same only. So just we need to compare. So to compare the equation with the standard form, that's why you have to write in this way. Okay, x by 3 plus y by 4 plus of minus z by 2 is equal to 1. So this is the first part of this question. Intercept form में reduce हो गया. अभी second part क्या है? Also find the x, y and z intercept. A is called x intercept, right? So A means the denominator of x. So here what is the denominator of x? 3. So here 3 is the x intercept, 4 is y intercept, and minus 2 is the z intercept, not 2. Minus 2 is the z intercept. So ऐसा टाइप का ही क्वेश्चन आता है इंटरसेप्ट फॉर्म से. कभी कभी क्या होता है, ये इंटरसेप्ट दे देता है and you are asked to write the equation of the plane. So if intercepts are given, then it is very easy to write the equation. So intercept मतलब a b c का वैल्यू दिया हुआ है. Just you have to replace this a b c by x by 3 for example, y by 4 minus z by 2. This is equal to 1. That's it. This is the equation of the plane in intercept form. So either equation दे देगा, you have to reduce it into intercept form, or intercepts will be given, you have to write the equation. That's it. So intercept form से ऐसा मॉडल का ही क्वेश्चन आता है. You have to remember this equation. Okay, x by a plus y by b plus z by c is equal to 1. So ये हो गया intercept form. Next will come this is important. Plane passing through the intersection of two given planes. फिर से एक बार मैं रिपीट कर रहा हूँ हेडिंग. This is the fourth one. Okay, first one was equation of a plane in normal form. Second one, today only I have explained equation of a plane perpendicular to a given vector and parallel to and passing through a given point. Third one, equation of a plane in intercept form, and this is the fourth one. Equation of a plane passing through the intersection of the two given planes. That means you can see the figure. There are three planes. P1 means the first plane, P2 is the second plane, and P3 is the third plane. जो मैं black color से draw किया, that is the third plane. Okay, this third plane, that means P3, is passing through the intersection of P1 and P2. It is difficult to draw the figure, three-dimensional figure on plain paper, but still you just imagine it. The black one is the third plane, whereas P1 and P2 are the first two planes, and the third plane is only passing through the intersection of the two given planes. तो मतलब P1 और P2 के बीच से जो थर्ड प्लेन है जा रहा है, वो थर्ड प्लेन का इक्वेशन फाइंड आउट करना है. प्लेन पासिंग थ्रू द इंटरसेक्शन ऑफ टू गिवन प्लेन मीन्स दिस प्लेन मीन्स P3. मैं यहाँ पे मेंशन कर देता हूँ, दिस प्लेन मीन्स P3. Okay, so that means you have to write the equation of the P3 by using P1 and P2. How can a plane passing through the intersection of two planes? There are two equations, vector and Cartesian. Okay, first I will write the vector equation. कैसा है? Let P1 and P2 be the two given planes. Let their equations be, say, r dot n1 is equal to d1 and r dot n2 is equal to d2. I have written in vector form. The equation of these two planes are in vector because first of all I will discuss the vector equation of the third plane and then I will discuss the Cartesian equation of the third plane. Okay, so let the equation of P1 be r dot n1 equal to d1, whereas the equation of P2 be r dot n2 is equal to d2. Then the vector equation of P3 is r dot n1 plus lambda into n2, which is equal to d1 plus lambda into d2. This is the equation of the third plane in vector form. Okay, equation of the plane passing through the intersection of two planes. Suppose there is a book, ये इसको पकड़ लो के ये पार्ट, दिस इज फर्स्ट प्लेन, दिस इज सेकंड प्लेन, और ये दो प्लेन के बीच में से एक प्लेन जा रहा है, दिस वन. Okay, so this plane you have to find the equation of this perpendicular plane which is passing through the intersection of these two planes. ठीक है, वो P3 का equation find out करना है, and this is the equation of P3, r dot n1 plus lambda into n2 which is equal to d1 plus lambda into d2. Okay, note down this equation. You have to remember this equation. This is the vector equation of a plane. Now the Cartesian equation is very simple. Cartesian equation. So for Cartesian equation, let us consider the equation of P1 be a1x plus b1y plus c1z minus d1 is equal to 0, and the equation of P2 be a2x plus b2y plus c2z minus d2 is equal to 0. Therefore, the Cartesian equation of P3 is a1x plus b1y plus c1z minus d1 plus lambda into a2x plus b2y plus c2z minus d2 is equal to 0. ज़्यादा कुछ difficult नहीं है. First equation of the plane plus lambda into second equation of the plane is equal to 0. This is the equation of the third plane in Cartesian form. Okay, and this one is the equation of the third plane in vector form. Note down these two equations, Cartesian equation, vector equation. ठीक है, यहाँ से mainly ये part से long questions ज्यादा आता है. This is important only. Okay, दो प्लेन के बीच में से एक प्लेन पास हो रहा है, वो प्लेन का इक्वेशन फाइंड आउट करना है. दैट इज द थर्ड प्लेन P3. ओके, नाउ आई विल गिव सम एग्जांपल, तो फिर और क्लियर हो जाएगा. सो लेट अस टेक वन एग्जांपल of the last part which I have discussed just now, that is the equation of a plane passing through the intersection of the two planes. Okay, so the question is, find the vector equation of the plane passing through the intersection of the planes, these two. That means you are asked to find the vector equation of P3 which is passing through the intersection of P1 and P2. Okay, and also the plane is passing through the point 1, 1, 1. वो मैं बाद में आ रहा हूँ, ये point के बारे में मैं बाद में discuss कर रहा हूँ. First of all, just you see up till here, that is the vector equation of the plane passing through the intersection of these two planes. So we all know the vector equation of a plane passing through the intersection of another two plane is r dot n1 plus lambda into n2. This is equal to d1 plus lambda into d2. Yes, So we can say that the equation of the third plane will be this one only. For this, we should know the equation of first and second plane also. So here the equation of the first plane is in the form of r dot n1 is equal to d1, whereas the equation of the second plane is r dot n2 is equal to d2. ठीक है? So clearly here the first two equations are given, which are in vector form only. So let the equation of P3 according to our figure be r dot n1 plus lambda into n2, which is equal to d1 plus lambda into d2. This is, say, equation number 1. Now, according to question, we know the equations of P1 as well as P2. That means we can say that here N1 is this one, N1 bar is this one, whereas N2 bar is this one. So therefore we can write, which implies R dot, put the value of N1, that is I cap plus J cap plus K cap plus lambda into 2I cap plus 3J cap plus 4K cap. This is equal to D1 plus lambda into D2. That means 6 minus 5 lambda. D1 is here 6, whereas D2 is minus 5. This is, say, equation number 2. This equation can be written as R dot 1 plus 2 lambda I cap plus 1 plus 3 lambda j cap plus 1 plus 4 lambda k cap, which is equal to 6 minus 5 lambda. This is, say, equation number 3. यहाँ पे मैं क्या किया, इक्वेशन 3 में जस्ट आई कैप, जे कैप और के कैप का कोएफिशिएंट कॉमन ले लिया. ओके, व्हाई वी नीड टू टेक कॉमन? बिकॉज द प्लेन is passing through this point also. That means 1, 1, 1. जब थर्ड प्लेन फर्स्ट और सेकेंड प्लेन के बीच में से पास होगा, that means वो दो प्लेन कोई एक पॉइंट में इंटरसेक्ट किया, वो पॉइंट का वैल्यू दिया हुआ है, कोऑर्डिनेट दिया हुआ है, that is 1, 1, 1. ये पॉइंट के बीच में से ये थर्ड प्लेन पास हो रहा है. ठीक है? So here the point of intersection is also given. ठीक है? Now, since you are asked to write the vector equation, so therefore you have to represent this point of intersection is also in vector form. That is, here r bar is equal to I cap plus j cap plus k cap. What does it mean? Since the plane is passing through the point 1, 1, 1, so that's why you have to write these coordinates in vector form only. Now put the value of r bar in equation number 3. Why we need to put in equation number 3? What is the use to get the value of lambda? Because here lambda is unknown, right? Which is a scalar quantity. So that's why to find the value of lambda, we have to put the value of r bar in the third equation. So third equation implies I cap plus j cap plus k cap dot 1 plus 2 lambda I cap plus 1 plus 3 lambda j cap plus 1 plus 4 lambda k cap. This is equal to 6 minus 5 lambda, which is equal to 6 minus 5 lambda. Now find the dot product on left hand side. I cap dot I cap is 1, we all know. So 1 plus 2 lambda plus 1 plus 3 lambda plus 1 plus 4 lambda is equal to 6 minus 5 lambda. So that is 14 lambda this is equal to 6 minus 3, that is 3. So lambda is equal to 3 by 14. Now we know the value of lambda, but सिर्फ lambda का value से काम नहीं चलेगा. Now you have to put the value of lambda either in the second equation or in the third equation to find the vector equation of the plane. Okay, now put the value of lambda either in the second equation or in the third equation. Let us put in the second equation now. Put the value of lambda in the second equation. So second equation implies r dot I cap plus j cap plus k cap plus, now here lambda is there, put the value of lambda, that is 3 by 14. 3 by 14 whole into 2i cap plus 3j cap plus 4k cap, which is equal to 6 minus 5 lambda. That is r dot. Now if you want to take I cap common, again you can take I cap common. So यहाँ पे रहेगा 1 plus 6 by 14. 1 plus 6 by 14 I cap plus 1 plus 9 by 14 j cap plus 1 plus 12 by 14 k cap. This is equal to 6 minus 5 into 3, and that is 15 by 14. So which implies r dot 20 by 14 into I cap plus 23 by 14 into j cap plus 26 by 14 into k cap. This is equal to 69 by 14. Now if you take LCM on left hand side, तो 14 eliminate हो जाएगा from both side. Then the equation is r dot 20 I cap plus 23 j cap plus 26 k cap. This is equal to 69, which is the required equation of the plane passing through the intersection of these two planes and also the point 1, 1, 1. Generally ये टॉपिक से लॉन्ग क्वेश्चन ही आता है, आइदर 4 और 6 मार्क्स का क्वेश्चन आता है. ठीक है, some more questions I will discuss in the next class. Thank you for today.